Answer to this one should be 5. Answer to this one should be -3. Answer to this one is 3.
We don't do class. Thanks. Have a great day.
For this problem, you should have x equals -2 plus 1. You do the opposite of this over here. So the answer is -1. This problem, you should have -x equals 4 and do the opposite of this over here, -2. Answer is 2, but not yet, not the final answer. You divide it by -1 to get rid of this. So the answer is -2. You need 2x equals 23 minus 1, the opposite of this on the right side. So 2x equals 22 and divide both sides by 2. These cancel out and you're left with 11. Alright, we have 5 out of 6 with homework, and that translates into a percent of 83. If you have credit for your homework, pick a number from 1 to 20. The winning numbers today are 7, 10, 11, 13, and 15. Here's a multiple choice before we go through the homework answers. What is the y-intercept? I need the block letter only. Yesterday I showed you how to find the y-intercept using the same way you've always done, by converting to y-intercept. Here's another way that you might find useful. If you're looking for the y-intercept, put a 0 in for x. And when you put a 0 in for x, cancels it out. So look what you're left with. You're left with 2y equals a -6, which you simply divide both sides by 2 and come up with an answer of -3. So the answer would be A. There's another way that you can find it. Homework answers. On number 1, you should have -5 for the y-intercept, and then 3 1/3 for the x-intercept. If you express it as 3.3 repeating, that's fine too. You have 2 answers to find for 1 through 5. So we'll make those a half point each. Each intercept is a half point each for 1 through 5. -5 and 3 1/3. For number 2, you should have the y-intercept as 3 and the x-intercept as 2 2/5. For number 3, the y-intercept is -3 and the x-intercept is 1. On number 4, it's a -2 for the y-intercept, -8 for the x-intercept. Number 5 is -3 for the y-intercept and 9 for the x-intercept. Here's your graph for number 6, and 6 through 10 are 1 point each. Your equation should be y equals 50x plus 60. If you have that, then you have a fighting chance at the graph. Your scale could be different than mine, but as long as you're consistent with how much you go up and go over, if you have the right equation, then it'll be okay. I went by every 3 hash marks, I put a 1, and then a 2, 3, and 4, and so on for the months, so I could spread it out. And then for the scale going up the y, I went by tens on this one. There's the line. Now yours could look a little different, be slanted a little differently depending on how your scale is. Number 7, again, I went by every 3 hash marks for the months, and I did that for 6 through 10. The scale I put on the money for this one is I went up by 15 every 2 hash marks. So I have a lot of my graph that shows up in there. I can go clear out to 5 months if I extended it a little bit further. On number 8, I made the money 50. Actually, I went by 10 on all these, but I only wrote down 50, 100, 150, and started with 10. You don't have to write every single one of them. As long as you're consistent, you can go by a multiple of 50, 25, 100 in some cases. On this one, I wouldn't go by 100 because then the person would have to count, what's going on in between. But if you start with 10, 50, you don't even have to put the 10. If you go 50, 100, 150, they can see that you're going by 10s in there. And on 9, the scale I put on the y-axis is I went by 20 for every hash mark. So every 5 I would have 100, and then 200, 300. And for 10, I made the scale, again, 20, 40, 60, 80, 100, but I only wrote down the 20, the 100, the 200, and the 300. Here is the Common Core objective for today. It's the same as yesterday. We're going to be looking at labels and scales as well as x-intercept and y-intercept simultaneously. Here's example 1. Find the x and y-intercepts for 4x minus 2y equals 6. As with the warm-up quiz, or not the warm-up quiz, but the multiple choice, I'll show you another way to find the x and y-intercepts without having to switch to slope-intercept form. If I want to find the x-intercept, then I'm going to put a 0 in where you see y. If you're finding the x, put a 0 in for y. And when I put a 0 in for y, it's going to cancel out that y term because it goes to 0. And if it goes to 0, there's no sense in even having it in there. So you just have that small equation to solve, and you divide both sides by 4, and then simplify to 3 over 2. 3 over 2 has got to be converted to a mixed number, which would be 1 1/2. If you want to find the y-intercept, then it shouldn't be an equal sign, it should be a colon. If you want to find the y-intercept, put a 0 in for x. And when you put a 0 in for x, it's going to cancel out that term, and you're left with negative 2y equals 6. So divide both sides by a negative 2, and you end up with negative 3 for the answer. So this was the x-intercept, this is the y-intercept. Here's example 2. Find the x and y-intercepts for 2x plus 3y equals 12. I'm going to find the x-intercept first, and what do I have to do first?
Cancel out the 3y, or replace the y with a 0.
Yeah, replace the y with a 0. And since I put a 0 in there, what can I do now?
Take that out of the equation.
Yeah, just take that out because it turns to 0. So you're left with 2x equals 12. What's x going to be if 2x equals 12? Yeah, it'll be 6. So that's your x-intercept. To find the y-intercept, what do I have to do first? Yeah, replace the x with a 0. And what can I do now after I do that? Yep, you can drop that out and be left with 3y equals 12. So what would the y-intercept be if I divide by 3? It's going to be 4. Here's a speed problem. This goes to the first 4. Solve for x. Make a mixed number if necessary. To solve this, you're going to have to move this to the left side and change the sign. And then divide by what's with the x. So the answer is -4. This one's open to everybody. Move this to the other side, change the sign, and then divide both sides by what's with the x. Should be 5. Try this practice problem. For your x and y intercept, we'll start with the x, and that means we're going to put a 0 in for y, which is going to cancel out, and you're going to be left with 4x equals 10. If you divide by 4, you're going to come out with 5 over 2, but you must make it a mixed number, so it's 2.5 for the x-intercept. And for the y-intercept, you're going to have to put a 0 in for x. Cancels that out, and you're left with -2y equals 10. Divide both sides by a -2. You're going to be left with y equals a -5. There's the bonus. Alright, for the answer for this one, you're going to have 2x, and that's not going to show up very well, so we'll use this. 2x equals -12 plus 4. So 2x equals a -8, and divide by 2. So the answer is -4. This one goes to the first 4. You should have this moved over to the left to become positive, and then you're going to divide by 1/2. If you divide by 1/2, that's -4 over 1 times 2 over 1, which comes out to be a -8. This one is open to everybody. Move this over, make it -2/3. And you're going to have to divide by that -2/3, which is going to be the same as multiplying 6 over 1 by a -3 over 2. That's -18 over 2, which is a -9. Here's practice number 2. On the practice problem, we're going to start with the x-intercept and insert a 0. Not here, so this will be a strange looking x. There is where it goes. Cancel that out. You have 5x equals a -14. So divide by 5. Change it to a mixed number. -2 4/5. And then for the y, that should be a colon. For the y, we're going to put a 0 in for x. Cancels this out, and we're left with -2y equals -14. Divide by -2. You should get a 7. For this problem, you should have -x equals -2 plus 1. That's going to be a -1, but you divide both sides by -1 to get x equals +1. This goes to the first 4. Fractions only, if necessary, and mixed numbers. Move this to the left, make it a -3/4 x equals -9. Divide the -9 by the -3/4. That's the same as -9 over 1 times 4 over 3. That's a -4 over 3. So you end up with a positive 36 over 3, which equals 12. This one is open to everybody. You have to move this to the left and make it a positive 1/5 x equals 5, and divide the 5 by 1/5. That's the same as 5 over 1 times 5 over 1, which is 25. Here's example 3. A monthly cell bill is calculated by the following charges. Each customer will pay a flat fee of $30 per month, plus 25 cents per minute for each minute over 300 minutes. Create an equation, not and equation. Thankfully it's in black and I can mark it out. There we go. Create an equation that represents this billing cycle and graph it using your own scale. So where would I start? Okay, so y equals 25x plus 30. Alright, so Mick Dame says we're going to use y equals 25x plus 30. Does anybody agree? Why not?
Because you need it, because you don't even do 300 minutes. Like, I feel like it should be like plus like 300.
Well, from yesterday, what variable did we use for months?
X.
We used x for months, and y was the money. But in this problem, we have a different thing going on. We have to pay per minute instead of per month, and the whole thing goes for just a monthly charge. Yes? 30x. Well, the flat fee is in the right place. It's at the back end. It is 30. The cents, though, is 25 cents. The way it's written right now, we have $30 and $25. 0.25, right, so we will revise this and make it 0.25x plus 30. Now, is there anything else wrong with this? What's wrong?
You don't have the 300 minutes.
Ah.
25 cents per minute for each minute over the 300.
Yeah, it's going to be 300 minutes that's got to go in there somewhere. Bartley.
You go do your equation first, and after you figure it out, you figure out how many minutes you go over, then kind of step back.
Yeah, he has an idea there. Well, here's what Bartley said. Bartley said that we could really just leave it the way it is right here, as long as we stipulate that x equals what?
300 minutes.
X doesn't have to equal 300 minutes. It could be what? Every minute over 300. So if you set the x equal to every minute over 300. So minutes over 300, and we stipulate that we put that in there, then it would work out. There's also another way you could do this. How would I figure out the minutes that are over 300? Let's 300 minus, close. What if I use 600 minutes? What would I do?
You do 600 minus 300.
600 minus 300, right. So what if I use 500 minutes?
500 minus 300.
500 minus 300, and if it were 1,000 minutes, 1,000 minus 300, so the amount of minutes that you use can change. And when things can change, what do you use to let something represent that? X. So we could also do this. You could also let x equal not the minutes over 300, but the minutes used. And if I did that, I would have y equals 0.25 times something that's going to represent how many minutes that have been used over 300. So if X is the minutes used, what do I do to X to find out how many over 300 minutes that is? Here's your big chance, Johnson. You've been waiting for this.
What?
You put the 300 in here. Here it is.
Like,
If I use 500 minutes,
we already had, and we took the 300 away, right?
took the 300 away, so what do I put in the parentheses?
200.
No. Bartley.
Minus 300.
Yes, that's right. Bartley was about to have a fit.
It's clicking now. I got it.
There we go. So now we have to go back and make sure it makes sense. You're paying 25 cents per minute over 300, and there should be another 0 in there. And 25 cents for each minute over 300. And then your flat fee of $30 is out here. Now, looking at this, it would be kind of difficult to graph that. So there's something you would have to do to this equation in order to graph it. You want to put it in y equals mx plus b form. You need a y, an equals, a slope, an x, and a number at the end. What we have is a y equals a number, but we have this parenthesis here, and then plus 30 at the end. Bartley.
I found out what your number in parentheses is first, and then multiply it by 0.25.
Well, you wouldn't have to do that to graph it. You wouldn't have to do that to graph it. But there is a way we can change this. Do you remember what to do when you have an item right up against a set of parentheses? What operation is between this 0.25 and this parenthesis?
Multiplication.
Multiplication. And when I have something right here and two items inside, what can I do to get rid of the parentheses?
Multiply by 0.25.
Right, multiply each of these by 0.25. So y equals 0.25x minus, and what is 0.25 times 300?
So,
75, and then plus 30. Well, here's what I have now. I have a y equals a slope, an x, but I have two numbers at the end. I only need one. So what do I do with this and this? Darnell.
75 plus 30.
Close.
Negative.
Negative 75 plus 30, right. So y equals 0.25x minus 75 plus 30 would be a negative 45. So there's your equation. And you could go graph that.